Okay, as promised, here we are in the house, and you can see over here where the wires come in, the coax and the Cat 5. Usually tie them to a chair or something at the top, just so they don't get pulled out the window by accident somehow, like if a deer gets in them or something. It's maybe just my imagination, but who knows. Anyway, the coax goes over to a Wellbrook indoor ATU, which is kind of an amplifier and tuning unit, and then up to the Perseus. And the Cat 5 comes into a homebrew Vactrol controller device with nothing but a resistor and some parts inside to put variable current out to the Vactrol itself in the field. And we're looking here, remember we said we had a 135 degree facing DKAZ. This is a handy map, azimuthal map, that shows you 135 degrees centered on where we are here near Reedville, which is right about here, and 315 is off the back. So in order to get the DKAZ to work right, you want to make sure that you are nulling something right straight off the back or as close to it as you can get. If you don't, you're going to screw things up. If you try and take this antenna and null, say, New York City, that ain't going to work, because you're going to null New York City all right, but you're not nulling anything else. You don't know what kind of pattern you've got. So if you do it in the daytime when you're working with ground wave, which is what you really want to do, you got to look for something that's strong enough on the daytime to do that. So we've got a couple of stations I picked that are kind of in the middle of the band. One is 980 from Washington, D.C., which interestingly I don't see on here now. They have something from West Virginia, which is odd. But the station on 980 is a sports station from D.C., and 920, WURA in Spanish, is in Quantico, Virginia, which is just south of D.C. It's 312, so that's pretty close. So we're going to look at 980 and 920. This is the Perseus screen, and we're on 980 right now, and we have the Vactrol all plugged in. If we unplug it, you watch the S meter and this little graph down here. All right, so we got about 50 for our dBm signal strength. All right, if I plug it in, we go down to nearly 80. So we're taking 30 dB off of this. That's not right. Yeah, that's right, yeah. So if I turn it, the knob, this is the knob on the Vactrol, and you can see we're getting a nice null here. We can get it down to maybe 85. So that's as low from down to 85 from 50. All right, that's 35 dB. That's not bad. If we go down to 920, we're basically burying somebody, and that's going to be our poor little WURA in Quantico. This is what they sound like normally. All right. And that's at 62 dB. If I plug it in, I'm basically burying it in the noise, which is 95 dB or so. So we're getting a lot of cancellation here. All right, now, and that's, you see the position on the Vactrol for the vernier. I mean the white line. All right, if I go now to 880, I'm gonna be looking at New York. All right, if I take and unplug, I got about 71 or 72, and if I plug it in, I'm nulling it down to about 79. And that's not so terribly unexpected, because it's just on the 90-degree edge to New York of the beam, and you're supposed to be getting a little more than 6 dB down there for your null. This thing has got, I'll just draw it. This thing has got a pattern out the front that looks something like this. All right, and the null off the back is all this, and that's what you're looking at. It's pretty broad, and I find it's a little broader than the models show. But that's what we're getting. All right, and I'm going to go down through here, and I'll take a recording and make plugged and unplugged conditions for the Vactrol, and then we can take a look and see what we actually can plot you know, what the amount of attenuation was at various angles around here, off the back, off the side. There should be none off the front. There's not very many stations to look at off the front in the daytime anyway. And it should be interesting. And that's basically how it works.